All right, now we're going to complete the second part of our extra low voltage switching lab. We just completed doing the extra low voltage switching for the GE system. Now we're going to have a look at the Douglas system. A little bit different method of wiring with regards to conductor colors. The same concept is still in place here. Now we have a different Douglas system here, and I'm just going to show you the back side where we have 4 different relays. 1, 2, 3, 4. This again would be our higher voltage side. In this case, these are all rated for 120 volt. So we have our connections on the 120 volt side over here, and then we have our low voltage side here. We have the relays are physically mounted in the center barrier in order to isolate extra low voltage from a higher voltage. We need to be able to separate different voltages according to our CEC within an enclosure. So we have put this metal bracket in the middle, and our relays physically get connected in there, and they have the lock nuts on this side to secure this side of it. But this is all one relay, second, third, fourth. Okay, that is all one component. And then we have our transformer here in order to provide power to the low voltage side for this lab here. Okay, you'll also notice on the low voltage side of the relays that now we only have red and white conductors. So a lot fewer different color conductors on the low voltage side for the Douglas system. So the coloring system for Douglas is going to be a little bit different from what we've seen in the GE. Our switches are a little bit different from the GE system. Okay, so here we have 3 switches that are all enclosed, and this would be typical, for example, for a single gang box. And we can actually easily put 3 switches in there. Just to show you on the back side, that is all one unit there. There are 3 switches within the one unit. And there is a common connection with our white connection feeding into each one of the 3 switches. And then we have 3 switches coming out and being fed there, 1, 2, and 3. And white is common already internally within the system there. So I just wanted to show you that so you can understand the wiring. Okay, so I'm just going to start by bonding out the systems here for the first lab. So for the first lab, you need to be able to make sure that you do a schematic drawing to show each one of our labs. Then when you're done with the schematic, then do up a proper wiring diagram for each and every part of extra low voltage. Okay, so on the Douglas system here, these connections here, the red and the blue, represent the low voltage side, the control side of our relay, and this side here represents the higher voltage connections. And again, the transformer being connected here, we're bringing in our power supply to feed power to the transformer so we can get our output voltage on this side. So these connections here are physically these connections here for the transformer. Okay, so I'm just going to start by connecting power up to our transformer. Okay, and again, you should have your schematics and wiring diagrams done at this point. So that's just feeding 120 volt into transformer. That'll give us our output voltages here, our correct output voltage. Okay, so that's taken care of. And we've got our bonds connection. So let's look at our first part of our lab for Douglas system on page 7. So this is objective 4. Want you to note that there are different manufacturers that use different color codes for your low voltage side. The Douglas system use these labs, they will use the following color codes. White will represent common to the switches. Red will represent the on coil of the latching relay, and the blue, for example, is the common to the latching relay and to pilot contact. Okay, what you'll notice in these switches as well for the Douglas system, we have LED lights that I'm going to show you once we get going here. Their colors where they automatically have an LED light to indicate that your switch is in the energized or de-energized position. All right, so exercise 1, it's asking us to draw a schematic with extra low voltage switch 1. So we're going to use switch 1, which will be this one here. It will control extra low voltage relay number 1, which is physically right here. This is the low voltage side, this is the line voltage side. So this is relay 1, this is relay 2, relay 3, relay 4. Okay. Switch 1 controls relay 1, which controls lamp 1. All right. And from this, you should have your schematic and your wiring diagram done. So what we're going to do, we're going to wire up the extra low voltage side of things. We are going to come from the white coming out of our transformer inside, and we are going to feed our switch. So we're going to go low voltage common, going to feed switch 1, which actually internally feeds all 3 of these simultaneously. We are going to come out of our switch 1 red, and we are going to make a connection to the low voltage side of our relay number 1, our latching relay. So we made that connection, and then the next connection for the low voltage would be from low voltage relay back to common power supply for low voltage. And there we go. Much more simple. Those are all of our connections for our low voltage side. We're done. Okay. Now what we're going to do in order to have relay number 1 control light number 1, we need to bring power from our supply into our latching relay, and then come out of latching relay to feed our load here. So I'll do that right now. We're going to take our ungrounded conductor, and we are going to feed into our latching relay. Then we're going to come out of our latching relay number 1, and we're going to feed light 1, the only one that we have. And then in order to complete our circuit on the 120 volt side, we will run a conductor for our identified back to our source. So now we're done the 120 volt side. So let's try this and verify its functionality. The switch 1 should control relay 1 that controls light 1. Well, you'll also notice with these switches here that there is no left or right. It is one solid button here. So it doesn't matter where I actually touch this button. I hit it once, that will latch my relay and pull my connection into a closed position. And then when I hit it a second time, it'll switch this into a closed position and energize my light. Okay, so let's try this now. On, off, on, off. And again, there is no separation of my switch. It doesn't matter what side I hit it on. Same thing happens. But what I do want to show you, try to bring this a little bit closer to you, you'll notice that there is a green LED and a red LED. My light is de-energized, so my green LED indicates that my my load is de-energized. And when I hit the button, I have the red LED, which indicates my load is energized. So red indicates on, green indicates off. So green is de-energized, red is energized. Okay, perfect. Wanted to show you that. All right. So this circuit is complete. One switch controlling one relay, controlling one load. All right. Again, make sure you do your schematic and your wiring diagram. Label your switch, your relay, your load, and your different colors on your low voltage side. Basically, your white, your red, your blue. Okay. We'll go on to the next step, which is on page 9. Exercise 2. We are going to have multiple switches control one load, which could simulate that we want to have a second location in order to switch or control one load. So exercise 2 is asking us draw a schematic diagram with extra low voltage switches 1 and 2 to control extra low voltage relay 1, and the relay operates a single lamp 1. So all we need to do is to create a second switch, 2 locations, control one relay, control one light. So in this case, what we're going to do is, because white is already common to each one of these 3 switches, all I need to do is to parallel switch 1 into switch 2. So I'm just going to grab another red wire from switch 1, connect onto switch 2. So that should be complete now. That's all I need to do to have